Balázs Varga. Oh, now I can hear that it's recorded on. Cool. So I'm Balázs Varga and I'm working at Allotropia. I was asked to talk a bit about charts, how the charts to API works, how to write new chart features, and just talking in general about charts. So let's start it. Okay, I cannot. Okay, now it's working. So let's talk a little bit about in charts, just general. So LibreOffice lets you present data graphically in a chart so that you can visually compare data series and view trends in the data. You can insert charts into spreadsheets, text documents, drawings, drawing layers, and presentations as well. Also, charts and these graphs can be powerful tools for conveying information in calc. Offers a variety of ways to present data. So let's talk about the available chart types. Calc offers a choice of 10 basic chart types with a few options for each type of chart. The options vary according to the type of charts you pick. The first type of choice is for two-dimensional charts, and only those types which are substitute for 3D charts like columns, bar, pie, and area charts give you an option to select 3D. Look, I think it's already, the screenshot is a little bit, it's from older version, but I think we already have a new chart type with this combination of bar and pie chart, which is not on the list, but yeah, I think it's already a master. I don't remember who implemented that. But other things that most of the types offers variants which are displayed as icons on the right of the dialog window. The three most common variants are the 3D, stacked, and percent charts. The stacked chart is utilized when the chart displays multiple data sequences stacked on top of each other. Percent chart is combined with stacked to stack the sequences in terms of their percentage contribution to the total. Let's talk a little bit about the charts elements, which are also quite important. So we have a lot of chart elements like titles, for example, which provides text boxes for entering chart title and subtitle as well. Also, we have titles for the X, Y, and Z axis, including secondary axis as well. We have legends, which specify if a legend should be included. And if so, we can decide on which place of the charts. We have different axes. As I mentioned, we can have primary and secondary axes, and also the X, Y, and Z axis, depending on its 3D charts or just 2D charts. We have data labels, which provide options for text attributes, whether to show categories and the position and rotation of the labels. These labels appear on each data point, but you can also set on different positions on the data points, but we will talk about that later. We can have also trend lines, which specifies the type of regression line to be used, options for extrapolation where the axis should intersect, or the name of the trend line, and whether and how the equation should be displayed. Also, we can have error bars on the X and Y. We can have X and Y error bars as well, which specify the error category of the values. Let's move to the chart2 API. The chart2 donates a second generation rewrite done to rid us of the full and twisted legacy chart code, which was the earlier version. The chart2 module was released 2 years before, in September, something like 2007, for the version 2.3. That release came with dire warnings, and it was a little bit unstable, as I heard about it in the beginning, but after 3 years, just before the LibreOffice was forked, it was quite stable by that time, around 2010. The chart2 model is quite complex. It simplifies 4 kinds of operations. The creation of a new chart in a spreadsheet document based on a template name. The accessing and modification of elements inside the chart, such as title, legend, axis, colors, or any kind of properties. The addition of extra data to a chart, such as error bars, trending lines, or secondary axis. The fourth one, to the embedding of a chart in the document, other than a spreadsheet, like into text documents or slide presentations. Okay, let's start with the first one, to creating a chart in a spreadsheet. For that, we use the Xtable chart supplier interface of the spreadsheet service. Is used to create and insert a new chart into the calc document. This creates a chart that uses data from the xchart.array interface of the underlying cell ranges. A generic way to create chart is to insert an OLA shape into a draw page and transform it into a chart setting a class ID. Let's move on to these table charts. A spreadsheet is one single sheet in the spreadsheet document and offers this Xtable chart supplier interface that is required by the service of the spreadsheet. With this interface, a collection of table charts that are a container for the actual charts can be accessed. To retrieve the chart document model from a table chart object, you can use the method this getEmbeddedObject. Also, just some note that when we are creating a chart, the default chart type is the bar diagram with vertical bars. We're using the template charts when we create that, and after it was created, we can modify for any kind of other chart types. Okay, so still about creating the chart, there is some example code using the chart Uno API on the right side. So the argument passed to the chart2@table chart function includes the new chart name, the cell range used as a data source, and the chart's position and dimension when drawn in the calc window. The position is a cell name, the A1, which becomes the location of the top left corner of the chart in the calc window. The name is converted into a position by calling the getCell position function. The size of the chart is supplied as a millimeter wide and height argument and converted into a rectangle to the 1 per 100 millimeter units. Let's move on to how we accessing to a chart document. We also have on the left side some example using the chart API. Although the chart to this add table chart function adds a table chart to the spreadsheet, it doesn't return a reference to the new chart document. That's obtained by calling the getChartDoc function, which accesses the spreadsheets collection of table charts, searching for the one with the given name. The matching table chart service is treated as an X-embedded object supplier interface, which lets its embedded chart documents be referenced. About this code on the left side, we will discuss in details in the later slides. Let's move on about initializing the chart document. The chart document is initialized by linking 3 components: the chart template, the chart's diagram, and the data source. The first line converts the E15 to G21 range into a data range, which is passed to the insert chart function. And then the A22 string is the dimensions specify the position and the size of the charts. And the last argument column is the desired chart template. Apart from the graphical objects, the chart document is linked to some data. The required service for the data component is the chart data. It is used for attaching data change listener and querying general properties of the data source, such as the number to be interpreted as not a number, or as a missing value. The derived class is the chart data array, allows you to access to the actual values in the chart. Okay, the next one still the same. It's also have on the left side an example with a lot of options and settings for the chart elements. The following example also shows how to insert the chart into the spreadsheet document and retrieve its chart document model. The example assumes that there is a X spreadsheet to insert the chart and an array of cell range addresses that contains the regions in which the data for the chart can be found. So also this insert chart creates a new chart document by calling the add table chart function and using the get chart doc function, and then proceeds to link the chart template and the diagram and the data source. How we get the data source from the charts, which is one of the most important part. The properties passed to the X data provider, the create data source function specify more details about the format of the data. The data for each graph is organized into columns, with the first cell being the label for the graph. And the has categories property is set to true when the first column of the data is to be used as x-axis categories. So the data provider converts the chart's data range into an X data source. From that, we can get the data source and the data series, which contains a lot of data about the series on the charts. If the data stored consists only of floating point numbers like double values, the returned instances should also support the service called numerical data sequences. If the data stored consists only of strings, the returned instance should also support the service textual data sequences. Okay, the next one is accessing and modifying charts elements. We didn't discuss about it. So the important service for chart is, as I mentioned, this chart document. The chart document contains all the top level graphic objects such as legend, titles, as I mentioned, many different kinds of titles like main, subtitle, and axis titles. These title objects, so this chart area, also we have this chart area, which is also always exists. This is the rectangular region covering the complete chart document background. The important graphical object is the diagram that actually contains the visualized data, which is two different things. The diagram coordinate system, the chart type, and the data series indicate that the diagram may utilize multiple coordinate systems, and that a single coordinate system may display multiple chart types. And a single chart type can employ many data series. Fortunately, this generally isn't often needed for the charts created by the insert chart function. In particular, the chart only uses a single coordinate system and single chart types. If, of course, there are exceptions for the combined chart types. Okay, so the next one is the accessing to the diagram. Now that we have the X diagram interface by using the getFirstDiagram function, it contains several useful methods like the getLegend, the getWall, getFloor functions, and its services hold many properties like starting angle, used in pie charts, and rotation, vertical property, for example, for 3D charts. The chart background is manipulated with a property set accessible through the xchart document getPageBackground function, while the wall is reached with the xdiagram getWall function. The documentation for we also have more documentation about the getPageBackground and the getWall methods. But this method doesn't list the contents of the property sets, so the easiest way of finding out what's available is by calling this showProps methods. Also, an important thing that most chart services inherit a mix of 4 property classes. like the style character properties, and also the style paragraph properties, and the drawing line properties and fill properties as well, which most of the base of the charts elements properties. Okay, how we access to the coordinate systems, which is also quite very important. The diagram's coordinate system are reached through the X coordinate system container with the get coordinate system function. And we have this container, and from there we can select the coordinate system. With this get core system function, we assume that the programmer only wants the first coordinate system. So we just return that value. The X coordinate system allows you to access also many useful methods about the coordinate system and the axis. You can also access, for example, this get dimension method, which give you back the dimension of the coordinate system. Also, you can get the get coordinate system type, which can be like polar or Cartesian and other different types. You can also set the axis with this services by dimension, where you can have at the x-axis interface and the dimension number. Okay, how we access to the chart types. And the chart types in a coordinate system are reached through the X chart type container with the get chart types function, and with that you can get the actual chart type. To change the type of a chart, we create an instance of the required diagram service by service name using the service factory provider, this X-chart document. This interface is available at the chart document model. After the service instance is created, set it using the set diagram method of the chart document. Okay, how we accessing to the data series. The data series represents a series of data points in the chart, changes to the look of these data points, for example, adding numbers next to the points, or changing their shapes and colors, etc. Many other things can be done in these two ways. Data series as a whole maintains a set of properties, most of which are inherited from the data point properties class. Typically, data point properties values are color, shape, line height, line color, or field properties. It's also possible to adjust points properties on an individual basis by accessing a particular data point by calling X data series to get data point by index. As the method name suggests, this requires an index value for the point, which can be a little tricky to determine. Explaining the second of the two chart changing methods called at the end of the original insert chart function. This set data point labels, which switches on the displaying of the y-axis data points as numbers. There is also an example code how we access to the data series and what we can set here. Using this set data point labels uses the chart to get data series method described on the previous slide, which returns an array of all the data series used in the chart. The set data point labels iterate through the array and manipulates the label property for each series. In other words, it modifies each data series property without accessing each point. The label data series property is inherited from the data point property. The label is of type of data point label, which maintains for show booleans for displaying the number and other kind of information next to the data point, depending on the label type value passed to the set data point labels function. One or more of these booleans are set, and the label property is updated by that. And yeah, this is an example from an earlier feature, which was implemented something like in 2020. In this case, which is quite close to it's related to the data point labels. In this case, the problem was that we couldn't move, like drag and drop the data labels from their fixed positions to a custom position. And we didn't have a leader line of the move labels. So it wasn't connected, the data label, with the related data point. The feature required many changes, like UNO-API changes, new properties, and a lot of modification and implementation in the chart controller side, some chart view changes, and a lot of filter changes. Also, it was quite complex how to calculate the new positions of the labels, which was quite different for each chart types. Like in case of bar charts, it was quite simple, but in case of a pie chart, it was a little bit more difficult because all these data labels have a fixed position around the data points. Like we can have a fixed position on the top, on the left, right, or the bottom side of the data point. And when we moved or drag and drop these data labels, we had to calculate, we had an absolute position and a relative position, and we needed the absolute position. And we had the fixed position, for example, from the top position of the data point, and we had to calculate from the fixed 0 position, which is the top left corner of the chart area. And we had this static top position, and by these two values we could calculate the position of the label. And we also had to add this leader line, which is connected the data point with the data label. So yeah, if for this feature implementation, it was required different modifications in the chart model. I've collected some patches here, which is related to this feature. The first one was, for example, this UNO API property modifications, which maybe we can check this just to show what modules was necessary to modify. First of all, we had to allow to drag and drop this object, which wasn't allowed in the first time. these things are always in the tools. So I had to allow this data label object type. With that, it was mostly possible to drag and drop. And then it was necessary to calculate the new positions, which most of this calculation was in the source tools folder and the view, where obviously it's quite obvious what is for the view folder. And yeah, for adding the new properties, it was necessary to add all these charts elements. We have different ideal files where you can add the specific properties. Like in this case, it was quite obvious that this relative position of the data labels, it was required to add the relative position ideal. So it was quite obvious to use that for these positions. It was necessary to add to the data point properties ideal. And and also it was necessary to add to the wrapper where we connected these properties and where we can set and check these properties, which are placed also in the chart2 source controller folder. The tests in this patch, it was also implemented some filter issue. So we have this chart2 import file for ODF and OXML as well. And it also have specific unit test for the ODFs, if I remember well. And let's see the other things. In this case, it was just some modifications. Missing tags from the original patch. It was quite a long time when I did that, so I don't remember everything. Also it's quite important if you implement a new calc feature when you are working on the filter parts. Mostly the OXML filters are in the OX source and the OXML chart folders. It's depending on the chart elements we import and set the properties in there. It's also some unit tests, which is every unit tests in the charts2 folder. So it's quite easy to find. The third one was the OXML export part. If you are working on the export part of the code, it's in case of chart, it's always quite easy to find because mostly all the chart export, it's in the export chart export CXX file, and also on the drawing.ml CXS file, which is not here. Maybe I had to modify something on a different patch. And after the calculation and the movements of this chart, of these data labels was correct, and all the filters was worked correctly, I had to add this line to connect the data label with the data points. And for that, I think it was it. This add leader line to the data label positions. For that, we already had some properties for these leader lines, if I remember well. But I also remember that I had to add it. Oh no, I remember well. I remembered wrongly. So in this case, I had to add this new property with this show custom leader line property, where we can set that we have a leader line connecting to these two objects or not. For that, I also had to modify this data series EDL file and to add this new Boolean property. Also, it's quite useful, and it's worth to mention that when you can, with the control plus F12 key combination, you can create a layout dump based on the X shape dumper, which is also very useful if you are trying to comparing two different charts, for example, on the layout level. I also used a lot for that when there was some issue, for example, in Writer, and it was just necessary to check that, for example, these two labels, data labels, are rendered on the correct position. And for that, it's just quite easy to use this layout dump XMS, and it was enough just to compare that. Yeah, I also added some useful informations about the chart too, models, and yeah, some other links which is worth to check later if someone is interested about more and the more details about the charts. And I think that's all. Any questions? Maybe.
Thank you, Balázs. Can you hear me?
Yeah, I can
Awesome.
hear you.
So I have just one question. Where can we find this presentation? And if we can have access to that, if you can drop a link in the matrix.
Yeah, of course. I will send you. Maybe I will upload.
Awesome.
I will upload somewhere to our next cloud server, something like that, and I can share there.
Works.
Yeah.
Awesome.
Anything works. So.
Perfect.
Yeah.
Thank you for the presentation. So in a traditional fashion, I go one by one and ask if anyone has questions, or you can write in the chat. Quaylen?
Yeah. Just during the week, I was looking at charts. I think at the very start you said something about a kind of a large API. We were using the X internal data provider, I think, which is the one for the presentation and writer case where you don't have a spreadsheet. Adding a column turned out to be a very, very difficult thing. Have you any thoughts on whether or not that's should be an easy thing to do and we were just doing it the wrong way, or have you found it difficult to manipulate the data for charts, not like the diagrams itself, the data underneath?
So if I understand well, your question is that how to add these columns to the charts, or maybe
yeah, exactly. Yeah, I mean, there's like, there's an X labeled data label, something like that, and you have to add in. Anyway, there's many steps. It seems to me.
Oh yeah, it's many steps. In the end, when you add these data points for the charts, yeah, it would be much more optimal if we could add these labels much earlier. But since we're using these kind of templates for creating the charts, we basically using from there, and I think to adding these data points earlier, it's hard to say. which would be the best or the most optional. When we already have a chart which is created, and we add, for example, an extra data points, that's also quite not too optimal, at least with my experience, because it can also be quite slow. For example, when you have 4 data points on the chart and you want to add a 5th one, it's still quite slow. But maybe not using or using somehow differently. These chart templates can be the first step to make it faster or something like that. At least this is my head at the moment. It's a good question.
Thanks. Miklos?
Right. So in many of your slides, you were showing these Java samples, this chart2 class and whatnot. That's not something that lives in the core Git repo, right? So I assume that some kind of Java wrapper around the API to make that less painful to use or something. Do you have some, like, is that code is living in some repo? We should be also.
This code also have on some, maybe on some wiki page I found that, which was also quite very useful to understand or present much more better these chart APIs, how it works across this Java code. Yeah, it's on a web page. I think it's on the useful links on the last slides. I put some links there. I think it's there between some of them.
And do you have any view on, like, this Java wrappers are using the UNO API, but then does the import-export filters and the UI also use this same UNO API, or is there an internal API which is different from that, or how does that work?
No, the filters are not using this API. I mean, in case of charts, we're using, I would say, only the UNO API for exporting the properties. I mean, there is no any exception. I think we have properties for everything in the charts too, almost everything. So we can get these properties from the shapes in the chart, and we just export them directly into the OXML tag or the ODF tag. This is the same on the opposite way. When we import these properties from the XML, we just usually set these across on the UNO API, these properties. So it's not so complex and difficult, the filter of the charts, which makes it a little bit slower to export and asking everything across the UNO API. Yeah, I've heard some kind of complaints about that using only this UNO API for all the exports, it makes quite slower, I think. Yeah, and there is some true in that. And the UI, also in case of UI, most of the cases we also use the UNO API commands, like inserting a chart or modifying, for example, modifying a color in a data point. For that, you have to select a data point or a full data series inside the charts, and with that you have access to the wrapper, which will set the direct property of the selected objects, like data points, data labels, grid lines, or a lot of other things.
Thanks a lot.
Hello. The connection got a bit
Yeah, it's good. It's good for me. I'm waiting for the
Can you
next
hear me?
question.
Because
Yeah.
I couldn't hear for some time, but okay.
Oh, sorry.
Hopefully
But
everyone could hear. So next, Ash.
No, great presentation. No questions. Thank you.
Beautiful. Attila.
Hello. I just wanted to mention that about what Keolan already asked. I only found a way in dialogue model to insert sequence into chart. I mean, it has a lot of implemented code like generating new colors to the data series and similar things. But it's in the chart controller library, so I cannot reach it directly through API. Well, that's just my comment, but using this function seems to be okay. I mean, it's in the dialog when you click on inserting a new column, then this function is called. The only problem is that it is in the dialog code. Well, and I could ask another question. I'm not sure if there is some specialty with subtitle. I didn't checked it yet, but now I just realized that after I modified my chart, the subtitle just vanished. But I didn't even pick subtitle. Maybe the
but when did it happen? I mean, it's in an export or import or when?
I changed its data array values. I think I didn't change anything else. So it was a bit strange.
Yeah, it's quite strange because it can disappear. For example, for the OXML export, it's always disappear because the OXML it's not supporting any kind of subtitles. So yeah, when I fixed that issue, I had to merge the two. I had to merge the two title into one. So yeah, with the same properties, but just what you mentioned, modifying something on the chart and disappearing subtitles. I didn't meet these kind of problems.
You are right. There was an export too. Maybe that.
Oh yeah, that makes sense. That makes sense. For the export, it will disappear because the OXML is not supporting. But the content of the subtitle now, I'm not sure it was fixed 3-4 years ago. I don't remember, but it should still have on the main title with the formatted properties as well.
Okay, thank you.
Especially now that we can format the characters inside these titles, which was quite an old feature and it was implemented half a year ago or something like that. We can set different kind of character properties by each character on the titles.
Okay, thank you.
Thank you. Byram. Okay. Aaron. Clough.
Thank you.
Darshan. Thanks. Gulsha. Hossein. Jaume. João. Michael.
Great talk. Thanks so much, Byron. Very helpful. And the slides will be published somewhere, I assume, or at least we'll have a video, I suppose. But yeah, great. Thank you.
Yeah, sure.
Rashesh. Thorsten. Beautiful. Thank you, Balázs. Thank you, everyone that was able to join here. And as a reminder, this was recorded and it will be soon available in the Collabora Online TED Talk YouTube channel. Have a nice week. Bye-bye.
Thank you.
Thank you. Bye-bye. Have a nice weekend.